Stop guessing sales and speed limits. Use Algebra. Whether you're calculating a discount, converting miles to kilometers, or scaling a recipe, ratios and percentage are everywhere. In this lesson, we'll break down ratios, proportions, and percentages. The math that makes sense of real life. You'll see how a simple proportion can turn chaos into clarity. So, if you ever wondered how 20% off really works or why your speed kilometer seems to lie, stick around. Let's make numbers practical right here on our channel. My name is Mahmud Kasari. Welcome to Special K.
Hello everybody, hope you're doing well. My name is Mahmud Kasari and welcome to the module number 6 that we do have related to Algebra 101. As we saw in the previous module, we talked a little bit about the ratio, the rate, the successive percentage, and about the scaling and a couple of other subjects. And today, as I just promised, we are going to have a couple of examples, and actually it's more than a couple, try to see how we can apply them in a real time or real world situation. So without further ado, let's just start it. So let's start with the first example that at this point, we do have the ratio simplification. If you guys remember, for the ratio, we had some kind of two important definition. The one was about the rate, another one was about the ratio itself. So for the rate, when we do have those conditions that we do have some kind of a number on the top and on the bottom, so we do have as a ratio. So if you guys remember, we had two important definitions. The first one was about the ratio, when we are trying to compare the proportion of one unit and compare it with another one when we know both of those units are going to be the same. For example, we're talking about apples and apples, we're talking about apple and oranges, we're talking about the students and teachers. Both of them, yes, they're a little bit different, but still they're the same. But on the other hand, we do have something called as the rate itself. It means that the number on the top and the number on the bottom, or the two numbers that actually we are trying to compare, are from different kind of unit measurements. For example, when we are talking about the speed of some kind of vehicle and we say that it's 72 kilometers per hour, we are trying to compare distance and time itself. So there are some kind of different units. We have to be careful about that. So at this question, we do have the ratio of two numbers, the difference or the comparison of the number of boys and girls. Still, they're the same units, they're people, right? So at this point, we are trying to see that what would happen if you compare them, and is there any way that we can simplify them? And you guys know, by the simplification means that at some point, we can find one number, or maybe more than one number, that if we multiply, if we divide it by numerator and denominator at the same time, we can have a simplified version of our some kind of fraction itself. So again, for some of you that are not very familiar with that, in the previous videos I talked about it in my channel, so that doesn't get you any harm. So try to look at it to see what's going on. So let's look at this example. I do have a class, and inside that class we had 18 girls and 24 boys, right? At this point, I do have 18 girls, I do have 24 boys. And the question is, write and simplify girls over boys. We know this girls and colon is another one. For example, we do have it as over, and this is another way of showing the proportion of one number over another one, and finds the boys over total. So we have some kind of responsibilities right now. Find the number of girls over boys and find the number of boys over total. So first of all, we have to write down the thing that we have. We do have 18 girls, we do have 24 boys, and obviously the total number, if we add them up, would be 42. The first part of the question asks for girls over boys, so it would be 18 divided by 24. The second part asks for the boys over total, and that's it? Obviously not, because the question specifically mentioned write and simplify it. Again, we have to find a number that we can divide that specific number by both numerator and denominator. Still, we do have 18 over 24, and we can write it down like this. So what is the number that I can divide it by both of these, and I still, again, don't have any remainder, or I can divide it evenly. So that specific number would be 6 itself. By 6 and by 6, I do have it at 3 over 4. Can I simplify it more? No, I can't. Maybe some of you would say that, look, how we can find the 6. Again, in the previous videos, I talked completely about how we can find some kind of a factor or the prime factor of these two numbers. But at some point, some of you would say that, remember that, and I say that is totally fine. Think about the very first number that you can divide these two numbers based on that. So 18 and 24, obviously both of them are even, right? So So the very first number would be 2. If you do that one, you have 18 over 24, which would be 9 over 12. Another number that you can think of would be 3. So it would be 9 divided by 3, and it would be 12 divided by 3. We still doesn't have only one step. We do have 2 steps, but still we do have the same answer. So for the next part, we do have 24 divided by 42, right? So again, we can find the number as 6, 24 divided by 42, divided by 6, divided by 6. So we do have it as 4 over 7, and this is the very simplified version. The one thing that you have to know is that whatever you're trying to multiply, I divide any number by denominator or denominator, or on the other hand, when we're talking about equation, when you try to do this kind of operation with any other side, you have to make sure you are doing the same operation, multiply, divide, and also make sure the number that you're using is the same. Why? Because we are not trying to change the question itself. We are trying to simplify. Let's look at the second example. At this point, I do have the rate identification. As I just told you, the ratio and rate, they have two different definitions. They still have the same, some kind of way to find them, but they do have two different definitions. The ratio means that it compares quantities with same units or same type, like girls and boys, when we're talking about apples and oranges. On the other hand, rate means that compare quantities with different units or type. For example, when we are talking about the speed. So at this question, what do we do have? The question says, identify each as ratio or rate. I do have 12 cookies per batch. I do have 45 students over 3 teachers, and at the end I do have 72 bits per minute. So obviously when we are talking about the rate and ratio, the thing that we have to look is about the quantities and about the units. So when we say that 12 cookies per batch, obviously we are talking about 2 different units, right? A batch is the number of batches that we have, and after that we do have the number of cookies. So since these two are completely different, we say that we do have rate. Look at the next point. We do have the students, we do have teachers. Yes, they're different, but still the same type. All of them are human, all of them are people, right? So we can consider this one as the ratio. And at the end, we do have 72 bits per minute. Bits and minute are completely two different things, so we can consider this one as the rate itself. We also can see it over here. So again, the only thing that you have to know is that when you're trying to compare the quantities, make sure that they're either same unit or different, and based on that you can say they are either ratio or rate itself. Let's look at another question. Proportion, find the missing value. If you guys remember the last video, we're talking about the cross multiplication. The cross multiplication is a way when you have two fractions and both of them are the same. By this way, multiplying one nominator by the next denominator and multiplying the next nominator by the first nominator. By this way, instead of just having two fractions, you can have an equation that has one term in one side and another term in another side, and based on this way you can find the missing value. Imagine that I do have some kind of a question like this. I do have a proportion. I know x over 14 equals 9 over 21. The very first thing that we can do is about the cross multiplication. Multiply this and this guy by this guy and make them equal. So I do have 21x equals 14 multiplied by 9. 14 multiplied by 9 would be a number, and we know since we are looking for x, the only thing that I have to do, use the inverse operation. We remembered from the previous video, divide both sides by 21. So it would be x equals 14 times 9 divided by 21. Whatever the number is, we can find the x itself and do have as the 6 itself. So if you guys remember from all of my videos, previous videos, it doesn't matter, as whenever I started these videos, I already told you, try to double check your answers. Try to make sure that the final answer that you have, if you put it in the equation or in the main question itself, you still have that equation or you still have that equal sign. For instance, when we found out that x is equals to 6, the very simple way in order to see that answer is right or not is just put it there. 6 over 24, is it going to be equal to 9 over 21 or not? If it's yes, your answer is right. If it's not, your answer is wrong. That's a very fast forward way in order to find that you did it wrong or not. So I'm not saying that all the time you're going to face a problem, but it doesn't work. It's completely worth it if you are trying to make sure that your final answer is right or not, because maybe in some kind of the middle of the way you forgot one positive negative, you forgot to add two numbers, I don't know, but that by this way you can make sure that everything is right. Let's look at another example. At this example, we do have a recipe scaling. So if you guys remember, we talked about the scaling, right? Another form of talking about the proportion and one fraction is equals to another is about using scaling. and we are going to talk about the scaling in drawing and any other points. But at this point, let's focus on the recipe. What do we do have? It says that in the recipe we use 3 cups of flour for 2 cups of sugar for 12 cookies. It means that I do have 12 cookies, and based on this proportion, I'm using 3 cups of flour and I'm using 2 cups of sugar for that. Imagine that if I want to make 30 cookies, how much sugar I needed if I know that the flour is scaled to 7.5 cups. What the question says that at the beginning of the point we do have the original value. That original value says for 12 cookies you need 3 cups of flour and you need 2 cups of sugar. And at another point it says, imagine that right now instead of having 3 cups of flour, I do have 7.5. So obviously easily we can find the scaling number, right? 7.5 divided by 3, and after that we can find that 2.5 is the scaling factor. So at this point, if you also try to compare the final cookies with the original one, would be 30 divided by 12. So obviously still you can find the 2.5. So this 2.5 is something constant. And based on that value, the question asks, based on all of this thing that I told you, how many cups of sugar do I need in order to make this amount of number of cookies? So we know for the first part, flour got 2.5 times more. The number of cookies got 2.5 times more. So obviously the sugar is going to get 2.5 times more. So the only thing that you have to do, 2 times 2.5, and you have 5 as the number of sugars that you need, or 4 cups of sugars that you need for this scale. Another question that we have is about the percent of number. So I talked about it, that the percentage means the part divided by the whole and multiply by 100, which we call it as 100%. So at this kind of question, we do have some kind of the percentage, and we are going to have that. Either we have to multiply that percentage by the whole in order to find the part, or we have to do vice versa. It means that we have to divide the final number by the percentage in order to find the whole. I will talk about it. Let's just focus on this question. This question says that what is 18% of 250? So obviously when we are talking about 18% of something, this guy is whole, this guy is percentage, and after that we are trying to find what? We are trying to find the part itself. We are trying to see that how many of these $250 is considered as 18%. So it's not that hard. The only thing that you have to do, multiply 18% by 250, and you will follow it as $45. Maybe some of you would be a little bit confusing at this point that we do have the percentage. How come we do have some kind of decimal point now? Because in the previous video we talked about it, that whenever we do have the percentage and we want to compare it to decimal, it is very simple. Imagine that I do have the 18%, and the only way, or there's some very simple way that I can use it in order to compare to decimal, is that first of all I have to get rid of this percentage and divide it by 100. So I do have it as 0.18. This is my decimal. If I would like to convert the decimal point to a percentage, it's some kind of completely vice versa. I would multiply the number by 100 and I will keep this percentage value. So this is the part I know. 18% of $250 is going to be $45. Let's have this question backward. It means that at this point, instead of just having the number or having the whole number, I'm going to give you the part. And after that, I would give you, I know for a fact, this part is going to be, for example, 12% of the whole value. Right now, your mission is try to find the whole value. How we can do that? Let's look at the example. I do have a 30 is 12% of what number? It means that I know for a fact 12% multiplied by a number, for example, call it as z, equals to 30. I'm looking for z. How I can find it? Simple. The only thing that I have to do, I have to divide both sides by 12%. But as we know, multiplying or dividing by percent is not that kind of common. So the only thing that you have to do is converting 12% to decimal would be 0.12. So it would be 30 divided by 0.12, whatever number is that, and we do have it as 250. So at this point, we know the whole number is 250 itself. This kind of question is so simple. The only thing that you have to do, first of all, write everything down, whatever you know, and then after that, some kind of try to remember the formula that you used to have for some kind of percentage, for the whole number, find the relationship, and after that, just putting all of those pieces of puzzles inside that one, and after that, you do have the final answer itself. Let's look at another question. We are talking about percentage increase. So if you guys remember, we were talking about the discount, and at some point we were talking about increasing the number. And after at that point, we had a formula in order to find the increasing or decreasing in the percentage, some kind of way of declaring a number. So at this point, I do have a question. The question which says that imagine that we had a jacket, and jacket goes from $60 to $75. Find the percent increase. So obviously when we are talking about the change, at this point we do have the 60 to 75. So I do have the $15 increase, but I want to see in percent increase. So whenever we say that in percent increase or percent decrease, we are trying to compare the new value with our original one. Either the new value is bigger than or the new value is smaller than. Our mission here is trying to find that by how percent or how many percent. So at this point, we are going to use a simple formula. The formula is what? The change in percentage is equals new subtracted by old divided by old times 100%, right? So the only thing that I have to do, I have to find the amount of difference, which is $15, and then I have to use it what? I have to use it in this formula. So new subtracted by old divided by old. It would be 15 divided by 60 would be 0.25. Am I done? No, because the final answer should be in percentage. So I know for a fact that I had 25% increase. Again, be careful. Try not to divide the difference by new value. All the time we are looking original value or the old value itself. After that, let's talk about successive discounts. If you remember, guys, from the previous some kind of video, I talked about a condition that instead of just only having one discount, you have 2 or 3 or more than discount back to back. So at this point, you cannot just add discounts together side by side and say that I only found the final discount. No. At this point, we have to follow a very simple formula. What is that formula? The formula said that there's some kind of the new value is going to be old value or the price times 1 minus D1. The D1 is the decimal value of the first discount, multiplied by 1 minus D2. D2 is the decimal value of the second discount, by 1 minus D4, so on and so forth. So at this point, I do have a case that my original price was $120. Then I do have 20% of discount, and after that, I do have 50% of discount. So give me the final price. Again, the wrong way is that you can just add them up, 20 plus 50, and say that, hey, I got 35%, let's swipe that one. No. First of all, you have to follow this formula, putting some numbers, and after that, you can find the final price. So I do have 120 times 1 minus 0.2. What is 1 minus 0.2? Because the first discount was 20%. After that, what you got? $96. $96 is for the first discount. Then I have to apply the second discount. Is 96 times 1 minus 0.15 was 15%. So I do have 81.60 itself. So at this point, if you calculate everything, or if you want to find the final discount, you can subtract 1 by 0.18. 0.80 is the sum kind of 1 minus 0.2. This is the number that we found. And times by 0.85, which is another number that we found. So at this point, if you do this calculation, you can find out that it was 32%. Or if it is hard for you, again, try to look at the formula we used for the previous slide. That would be about the new value subtracted by old value divided by old value, and you still get the 32%. But remember, the number that you find would be negative, means that the percentage decreased in comparison to the previous question that was increasing. Right now, it is decreasing. So let's look at another question. Another question would say that about the scale drawing. If you guys remember, when we were talking about the scale rather than just having the cooking recipe we have, at some points we are working with big numbers, but we cannot show those, or we cannot physically visualize those big numbers into our physical thing, because that would be so huge. For instance, if I want to show you 20 meters, I cannot just show 20 meters on my paper, right? I have to scale it down, but I would make sure that I would write it down somewhere. If someone sees that, for instance, I do have the 20 meter, I would say that each centimeter we're going to consider as 1 meter. Whenever you see that 20 centimeter, actually I was talking about 20 times 20 meters, which is 400 meters. So we do have the same question over here. At this point, I do have a map that has a scale of 1 to 50,000. It means that whatever you see on this map as 1, 2, 3, 10, 20, whatever, you have to multiply by 50,000 if you want to find the actual value or the final value. So the distance between two towns is 7.2 centimeter on the map. What is the real distance between these two towns? Obviously, we know each centimeter as considered as 50,000 times more than the value that actually is. So the map scale is 1 to 50,000. And the only thing that you have to do is multiply 7.2 centimeter by 50,000 and you have this one. And you can convert this one to kilometer and you have 7.6 kilometer itself. Please be careful. Each meter is going to be considered as 100 centimeter and each kilometer considered 1,000 meters. So when you're trying to compare one to another, please be careful about that one as well. So now the final question would be about the speed conversion. So we talked a little bit about one type of conversion. Obviously, we do have different type of conversion, but one very common type of conversion is about converting the speed from kilometer to hour. Again, it's a rate, it's not a ratio, it's a rate. 1 kilometer to hour per hour to meter per second, or the vice versa. The only thing that you have to do, if you had the kilometer per hour, is going to be considered as a bigger one divided by 3.6, and if you do have a meter per second, which would be considered as a smaller one, multiply by 3.6. So we do have it over here. What is that? We do have a 108 kilometer per hour. Try to convert it to meter per second. So the only thing that I have to do, I have to divide it by 3.6, and I do have 30 meter per second itself. So guys, we just reached out the final part of the second chapter of module 6, when we were talking about the rate, about the ratio, about the scaling, some kind of the proportional, how we can simplify the fraction. And at this point, I can completely guarantee you have everything that you need for your exam, for the test, for your assignment, or anything. But still, if you do have any other kind of question, just comment me down below, and if I try to answer your question, if I don't, I will make another video and try to some kind of elaborate it as much as possible. Again, my name is Mahmud Kasari. This is Special K. Thank you very much for seeing this video. Please try to share and comment. That would be so helpful to me.